So in this video, we're continuing with task 8, but we're going to look at that second part on circles. Okay. So first of all, what is a circle? A circle is the set of all points that are a given distance from a fixed point known as the center. Okay, and they're the same distance, like all of these points on the circle are the same distance from the center. The center we call HK. Okay, so H is that X coordinate, and K is the Y coordinate, and we use H and K for the center of a circle. The fixed distance from the center to any point on the circle is known as the radius R. So I can pick the center and any point on it, and if I draw that, that is the radius. So you can draw the radius kind of an infinite number of times in this circle. Any segment that connects 2 points on the circle is known as a chord. Okay, so you're probably very familiar with radius. You're probably very familiar with diameter. You might not be as familiar with a chord. So a chord is if you have 2 points on the circle and you connect them with a line segment, that is a chord. And the most famous chord that most students are more familiar with is the chord that goes through the center. And the chord that goes through the center is called the diameter. Okay, so a diameter is also a chord, but if a chord goes through the center of the circle, then it's also called the diameter. Okay, so any chord that passes through the center of a circle is a diameter. And we are going to write the equation of the circle. So just like a line probably is the one you're most familiar with. A line has an equation. The equation of a line is y equals mx plus b. A circle also has an algebraic equation, and it's defined by its center and radius. So how the equation works is we have to know the center, hk, and we have to know the radius, r. And if we know those two things, we can write the equation of a circle. So for the equation of a circle, it is always parentheses x minus whatever the x coordinate of the center is. Then you close parentheses and you square that, plus, and then it's y minus the y coordinate of the center, close the parentheses squared, is equal to the radius squared. Okay, so x and y are always these variables in the equation. H, K, and R should always be replaced with numbers, and they will be given either in a picture or like written out on a problem. So we're going to start with being given the equation and then identifying the center and the radius. Okay, so one thing to note is the equation is always minus, you can see here and here, minus, but the center is HK. So the center is always opposite sign of what is between the x and the number. So for this one, we want to find the center. And the equation really should be like minus. So this first one is fine because it's -3. So 3, like my h is 3. But the second one, I really want it to be y minus. And because it's +2, I would need it to be minus a -2 because minus a negative is the same thing as plus. And so my K is -2. And so it's really just the opposite sign of what is in the equation. Okay. And then this, we want to be the radius squared. So we're kind of thinking of what squared gives me 36. And so that would be 6. Or to find the radius, you can think about the opposite of squaring something is I'm going to take the square root of whatever there is. And so the square root of 36 is 6. And so if your radius is not a perfect square, and just a reminder, a perfect square means that if you take the square root, you get a whole number. if it would be that you take the square root and you get a decimal, then you would need to like use this method for finding it. Most of the ones we will do will be a whole perfect square, so you can probably figure them out in your head. So when we write the center, I would write my center is 3, -2. We write it as a point. And then I would write my radius as equal to 6. Okay. So a few additional definitions, because there'll be a few on the homework asking about this. A secant line intersects the circle twice, but extends beyond the circle. So this green line is a secant line. It just keeps going because it's a line and not a line segment. And then a tangent line intersects the circle once. So this line here is a tangent line, this red line, it intersects the circle just one time at this point. So a tangent line pretty much lies completely outside the circle, except it intersects the circle at this one point. And then we have again a chord, which has its endpoints on the circle, the diameter, which is also a chord, but it goes through the center, and then the radius, which goes from the center to a point on the circle. Those are all of our different line segments or lines involved with circles. So let's look at question number 2. We want to, in the figure at the right, identify the coordinates of the center, a segment that's a radius, a segment that's a chord, a segment that's a diameter, and then identify the equation of the circle. Okay, so the center of the circle is here at point A, and the coordinates of this point are 0, 0, because it's located at the origin. We want to name a radius. So there's 3 drawn, but you could do other ones if you wanted to draw in, but based on the points given, we could give one of 3 answers. Between A and D is a radius. Between A and B is a radius. And then between A and C is a radius as well. And so for it to be a radius, you have to have the point at the center, and then that you have a segment between that point and another point on the circle. A segment that's a chord. Okay, so our chord has to have its endpoints on the circle. So if we look at this segment here, has endpoints on the circle. So we would say BC. Remember, we name a segment with 2 points and we put a line over it. And then a segment that is a diameter would be the only one that they really have drawn between points would be this line segment is a diameter because it goes through the center. There's again other ones, but we don't have like points on the circle to identify them. So we would say CD and put a line over it. And just remember, a diameter is always a chord. So you could also say for a segment that's a chord, it's also CD. Just sometimes there's always, sometimes never questions. So if the question was, is a diameter always, sometimes, or never a chord, you would say a diameter is always a chord. If they ask the question, is a chord always, sometimes, or never a diameter, you would say a chord is sometimes a diameter, because if, for example, CD is a chord that's a diameter, but CB is a chord that's not a diameter. And then we have to identify the equation of the circle. So for the equation, we need the radius in the center. So we already found the coordinates of the center, which is 0, 0. But then we need the length of the radius. So for the radius, because it's on a graph, we can count it. So I can pick any of the radii, AD, AB, or AC to count. So let's say I do A, B. And if I count from here to here, I go from here to here, which is 1, and then from here to here, which is 2. So the length of this segment is 2. So the length of the radius is 2. And then we always are plugging it into this equation. So for the exam, you will get one page, like one side, one page that you can write notes. So you probably want to write this formula down. So for this formula, what we do is you put parentheses, you always have x minus, and then whatever the h value is. And then y minus whatever the k value is. Remember, h is the x coordinate, k is the y coordinate of the circle. Equals, and then we put our r squared. And then if you can, you should simplify. So x minus 0 is just x, so this is x squared. Y minus 0 is just y, and 2 squared is 4. So this would be my final equation. So we're going to do question 3, and then you are going to do question 4 and 5 as part of a classwork activity in class. So in the figure to the right, identify the coordinates of the center, a segment that is a radius, and identify the equation of the circle. So we start with the center. The center of this circle is this point A. So point A, the coordinates are the x coordinate is 2, and the y coordinate is 3. We need to name a segment that is a radius. Now they didn't draw these in, but I do have points B, C, and A. So if I connected A to B, that would be a radius. So I put AB with the segment on it. Or I could also draw a radius between C and A. Okay, again, there's a lot more radii that you could draw, but they don't have those points on the circle. Also, you can do AB or BA, they're the same thing, or CA or AC, they're the same thing. And then we're going to write the equation. So again, the equation of a circle is this equation. So again, we need the center, which we have of 2, 3. 4, 2, 3, my H is 2, and my K is 3. And then I also need my radius. So I have to count the length of my radius when it's on a graph. I can count between A to B to A to C. But either way, I go 1, 2, 3, and the length of the segment is 3. And then I'm going to plug that in. So I have x minus 2 squared plus y minus 3 squared equals 3 squared. And I can't really simplify other than just squaring the 3. Okay, you don't have to like square the y minus 3 or the x minus 2. You just need to square the 3 squared. And the other thing is if one of your coordinates is negative, when you have minus the negative, you should always change that to a plus. So that is the equation of a circle. And again, we're going to look at questions 4 and 5 in the classwork. If you want to like look at it ahead of time so that you're more comfortable with those questions, you can try them ahead of time, but you don't have to.